So what we're going to do in this video is look at an application of integration. So previously what you've maybe learned how to do is find the area under a curve. So if we had the function f of x between the intervals of b and a, we can find the area under the curve that way. Well, essentially using the same method, and we can find the area of, the volume within that same function rotated round the x-axis, but with the formula of volume equals the intervals of b to a of pi times the function squared dx. It's important to note that that is not given in the exam, so you're going to have to remember it. Okay, but what you can do is think of it as these are all infinitely small circles. How do you find the area of a circle? Pi r squared, and that's actually where the formula comes from, because it's the sum of all these infinitely small circles all added together between b and a, hence why we get the volumes. Another thing to note as well when it comes to these sort of questions is, yes, we can rotate around the x-axis, but there's nothing stopping you from rotating around the y-axis. So when that happens, if you're rotating around the x-axis, your function needs to be explicitly in x. So conversely, if you're rotating around the y-axis, your function needs to be explicitly in y. Okay? So, calculate the volume of revolution obtained between x equals 1 and x equals 2 when the curve y equals x squared plus 2 is rotated about the x-axis. So firstly, rotating around the x-axis, we're already explicitly in x, so that's straightforward enough. So we're going volume equals the integral from 2 to 1 of pi times x squared plus 2 all squared dx. Okay? So let's take out the common factor of pi just to make it slightly easier. 2 to 1 between x squared plus 2 all squared dx. Okay? So the integral of that will become x squared plus 2 cubed all over 3 times 1 over the derivative of what's inside the brackets, which is x squared plus 2 between 2 and 1. That is 2x, so we get x squared plus 2 cubed all over 2x times 3, which is 6x, between 2 and 1. Okay? So we get the volume equal to pi times, substituting 2, we get 2 squared plus 2 cubed all over 6 times 2 minus 1 squared plus 2 all cubed all over 6 times 1. 2 squared is 4. 4 plus 2 is 6. So we're doing 6 cubed over 6 times 2 minus 1 squared is 1 plus 2 is 3. 3 cubed over 6. 6 cubed divided by 6 means we can just get rid of that one and change that to 6 squared. So volume equals 6 squared over 2, which is 36 over 2, which is 18. 3 cubed, 3 times 3 is 9 times 3 is 27. 27 over 6. over 6 is 4.5. So 18 minus 4 is 14. Minus a half is 13.5. So the volume is 13 pi over 2 units cubed. Okay? So it's just really, as long as you remember the formula and then correcting your units properly, it's actually no more difficult really than anything else. Okay? So what I'm going to do is show you what's going to look like a very similar question. Calculate the volume of revolution obtained between x equals 1 and x equals 2 when the curve y equals x squared plus 2 is rotated about the y-axis, not the x-axis. Okay, so if I were to quickly sketch that out, x squared plus 2 is roughly going to look like that. In the previous question, we found it between 2 and 1, rotated. Now what we're having to do is rotate it around the y-axis. Okay. The worst parabola I've ever drawn. So now it's going to be like that. So we've got some issues at first. The function is not explicitly in y, and also we're going to have to change the values of what we're integrating it between, because yes, it's 1 and 2 here. 1 and 2 here do not necessarily mean 1 and 2 on the y-axis. But straightforward enough. We have y equals x squared plus 2. So let's firstly find the intervals. So y is going to equal 1 squared plus 2 equals 1 plus 2, which is 3. And y is also going to equal 2 squared plus 2, which is 4 plus 2, which is 6. So we've already got the intervals. So instead of being between 2 and 1, it's between 6 and 3, but on the y-axis. And now all we need to do is change the function to be explicitly in y. So we've got x squared plus 2 equals y, so x squared will equal y minus 2, so x will be y minus 2 to the power of a half. So our volume is going to be from 6 to 3 of pi times y minus 2 to the power of a half squared d, it's not x anymore because we're in terms of y, dy. Now this nicely simplifies because square root times squared is just going to be y minus 2 dy. So we get pi y squared over 2 minus 2y between 6 and 3. So we get 6 squared over 2 minus 2 times 6 minus 3 squared over 2 minus 2 times 3. 6 squared is 36, over 2 is 18. Minus 2 times 6 is 12. 3 squared is 9, over 2 is 9 over 2. Minus 6. 18 minus 12 is 6. 9 over 2 is 4.5. Minus 6 is negative 1.5. They become plus 1.5. So we get 6 plus 1.5 is 7.5, or 13 over 2. Units cubed. Okay, so that would be how to do a volume of revolution around the y-axis. Okay, so do one more. So calculate the volume of revolution when the curve y equals x cubed between y equals 0 and y equals 8 is rotated about the y-axis. So first thing that we need to do is recognize that it's being rotated about the y-axis, so we need to have it explicitly in y. I'm also going to quickly sketch the graph to show you what it will visually look like. So x cubed roughly looks like that. So we've got 0 and we've got 8. Let's say it's there. So it's going to be that section rotated. So our intervals are already in y. So all we need to do is change the function to be explicitly in y. So if we've got x cubed equals y, that means x will equal y to the third. Okay. So then what we're doing to get the volume is the integral from 8 to 0 of pi times y to the third squared dy. So volume will equal pi 8 to 0 of y to the 2/3 dy. Add 1 to the power, we get 5/3 all over 5/3 between 8 and 0. So volume will equal pi times 3/5 y to the 5/3 between 8 and 0. So we're going to get 3/5 of 8 to the power of 5/3 minus 3/5 of 0 to the power of 5/3. So how are we going to work this out? Well, that is the cube root of 8 to the power of 5, because it's split it up into 8 to the third to the 5. The cube root of 8 is 2, so that really is just 3/5 of 2 to the power of 5 minus 0, because that's all going to cancel out. 2 to the power of 5 is 32. 2, 4, 8, 16, 32. So we've got volume equals pi times 32 times 3 over 5. 32 times 3 is going to be 66. So it's 66 pi over 5 units cubed. So that is volumes of revolution.